We live in a world where billions of people are connected all the time. They can communicate with each other anytime, any place. Soon we'll be able to communicate with almost anything, whether it's a machine or a human being. And this is going to lead to a digital, socio-cyber, physical environment of absolutely unimaginable proportions and complexity. The primary aim of our CDT is to understand, to design and to exploit the data and the infrastructure associated with this connected world.
This is a 4-year integrated PhD programme where we take students from the disciplines of electronic engineering, mathematics, computer science, and we've also had some physicists who've actually joined our programme. We also get people coming back who've worked in industry for several years to actually come back and refresh their skills and embark on a PhD.
I do come from a mathematical background and I wanted to have a better understanding of the new sector to me, which is communications. The first year is the thought phase, where there are many interesting modules, I would say, and many options to take. I feel more confident now that I've taken those modules and I've broadened my knowledge.
So my area of research is propagation models, which will help design the next generation of wireless devices and networks. In the first year, I had the opportunity to go to a training school in Dresden and an international conference in Graz. This really helped connect with the sort of international community working at the cutting edge of my particular research field, and it helps develop contacts as well as an opportunity to present my research and get feedback on what I'm doing and also learn from them.
My research is not only about theoretical work, it's also about investigating the practicality of using different algorithms and techniques and real-world measurements using the state-of-the-art technology we have in the lab, known as Massive MIMO. My sponsors, the BBC, are interested in this technology and they want to use it in the wireless studio and their outdoor environment to cover a major cultural or sporting event. So far we've conducted several trials with different companies and industry, such as BT, and we have also conducted collaborative measurements with a research team at Lund University in Sweden. Also, National Instrument is involved in this program.
The CDT program in particular has a unique emphasis in terms of theory and practical knowledge, because the students that have that practical knowledge actually end up being better employees, better researchers, and that cements that fundamental foundation in theory.
I'm an international student from Ecuador. I'm sponsored by the government of Ecuador, as well as from Keysight Technology in California. Through the collaboration with Keysight, my research had the opportunity to influence into the standards for the future 5G networks.
My PhD research was sponsored by BAE, which is an aerospace and defence company, and the focus of it was to work out novel antenna array designs for aircraft. One of the reasons I came to the University of Bristol was it's got one of the largest anechoic chambers of the universities in the country. And not just that, but the tools that have been developed to use the anechoic chamber to the limits of its capability have meant I was able to do a great deal of antenna array measurements in a short space of time, really accelerating my research. I now work as a senior research associate here on 5G and millimetre wave wireless. So we're working on ways to make a mobile phone signal go further, get a higher data rate and be more energy efficient.
I had the opportunity to meet people from industry and other universities, and also have attended several seminars and conferences. One was in Washington, which was a great opportunity for me to visit a different continent and get to be in big conferences and meet so many people. Bristol is one of the best cities in the UK to work and study and live, of course. It's a multicultural city, so you can meet people from all over the world, which is really exciting for me. As a senior research associate for 2.5 years now in the University of Bristol, I have been really enjoying doing this practical work, taking advantage of all the facilities that the CSN lab offers.
Blue Wireless has built a world-class engineering team here in Bristol. We've worked together with a number of students and we've found the kind of people that we need. 10% of our workforce are University of Bristol graduates.
Bristol is a great city to study, a great city to live in, so why don't you join us?
If you require further information on the Research Centre, please look at our website, which also gives details of funding and how to apply. And we certainly look forward to receiving an application from you.